What's up, guys? This is Waleed, and today's problem is tagging with Technetium. So they explain a little bit about it, but the questions start from here. One possible such tag is Technetium 99, which has a lifetime of 605 hours. So how many nuclei are required to give an activity of 1.3 micro CI? Okay. So from here, let's find the decay constant. And before we do that, let's change by 2. It's going to be equal to 6.05. Let's change it to seconds. So times 60 times 60. So this is minutes and this is seconds. So the half-life is going to be equal to 21,780 seconds. Cool. So that means that decay constant is going to be equal to natural log of 2 divided by 21,780 seconds, which will give us 3.182 e to the negative 5 second to the power negative 1. Okay? And from that, we change the 1.3 micro CI to BQ. So 1.3 micro CI is equal to what? If 1 CI is equal to 1, what was it? 3.7 times 10 to the 10 BQ. Okay, so from that I get that we multiply by each other. So 1.3 times 10 to the negative 6 times 3.7 times 10 to the 10. Okay, so for this guy I got 48,100 BQ. Now we use the decay rate equation, which is dn divided by dt is equal to lambda and the number of particles. So we have dn dt, which is this guy in here. So 48100, and then we divide it by the decay constant, 3.182 e to the negative 5. That will give us the number of particles. So the number of particles was equal to 1.511 e to the 9 particle. So this is the answer for number 1. Okay. So what is the decay constant for number 2? What's the decay constant for this isotope? We do natural log of 2 divided by 6.05 hour. I'm using this half-life because they're asking in hours in here. Okay, for this guy I got 0.11456. Okay, suppose that drug containing the amount of 99 TC in part A. So we have the number of particles in here. Were injected into a patient for 1.3 hours after it was prepared. What is the activity would be at that time? Okay. So what we're gonna do is we need to find what's n after 1.3 hours. So we're gonna use n equal n naught e to the negative decay constant times t. So the number of particles we have is 1.511 e to the 9, and then exponential minus. So here we need to make sure that both of them have the same units. So I'll use the second one, 3.182 e to the negative 5 multiply times, or actually they're using the hours in here, so I have to use the hours. Or I could change 1.3 to seconds, but I have the hours one. So 6.05 hold on. We're using this time in here, so it's 1.3 for the negative times the decay constant in hours, which is this one in here. It's 0.11456. Okay. So n was equal to 1.301 e to the 9. And then we do the same thing. We do dn divided by dt. It's going to be equal to n lambda. And dn dt is going to be, that's what we're trying to find, because they're trying to find the activity, what the activity be at that time. So n is 1.301 e to the 9 times the lambda, which is 3.182 e to the negative 5 second. I use this one, this decay constant, because I want it in decay per second, or the BQ, because the BQ is the decay per second, so we need to use the second to the power negative. Cool. So for this one I got 41426 BQ. But now if you look at the question, they're asking in UCI, micro CI. So the way we do it is 1 CI is equal to 3.7 e to the 10 BQ, and then 1 CI times 10 to the negative 6 is equal to 41426. They want to know how much is this guy in here. Okay, so multiply times this divided by that. So 41426 divided by 3.7 e to the 10. Okay, and for this one I got 1.119 e to the negative 6 CI, and they want it in micro, so the answer is just 1.119 micro CI. Cool. Alright guys, if you have any help, or if that confused me, leave me a message and I'll help you. I'll try my best. Alright, good luck. Bye.